The A340-300 and A340-600 electrical systems are nearly the same, so we will use the A340-300 system's representation. We will highlight the A340-600 particularities when appropriate. There are 4 engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG. For the A340-600, the IDG power supply has been increased. Each generator supplies alternating current, AC, to its own bus. Generator 1 to AC bus 1-1, Generator 2 to AC bus 1-2, Generator 3 to AC bus 2-3, Generator 4 to AC bus 2-4. AC bus 1-2 supplies TR1. AC bus 2-3 supplies TR2. The TR convert alternating current into direct current, DC, to supply their associated DC buses, DC1 and DC2. DC bus 1 then feeds the DC BAT bus. The DC BAT bus can charge the batteries or receive power from the batteries as required. This will be explained further in the normal operation module. The electrical system also includes 2 essential buses. The first one is the AC essential bus, fed by AC bus 1-1. The second one is the DC essential bus, fed by the AC 1-1 bus via the essential transformer rectifier. Essential TR. This is the basic electrical system. We will now introduce some other components which supply the basic system. The electrical network can also be supplied by the APU generator. These 5 generators are all identical, and 2 of them can supply the entire aircraft electrical needs. On the ground, the aircraft can be supplied by 1 or 2 external power sources. As a backup, there is an hydraulically driven emergency electrical generator, EMERGEN. It is powered by the green hydraulic system. The green system can be supplied by a ram air turbine, RAT, which extends in case of a severe hydraulic failure. The RAT is located under the right wing. A static inverter allows part of the AC electrical network to be supplied from the main batteries, batteries 1 and 2. The APU-TR is used to charge the APU battery. The APU battery is dedicated to APU start. Now, let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electrical pages. There are 2 ECAM electrical pages, one for the AC distribution and one for the DC distribution. Only one ECAM electrical page can be displayed at a time on the lower ECAM. For training purposes, We will show both at the same time. You can see that all the components we have talked about are displayed on the ECAM pages. Notice that each component has a title to aid identification. Let's briefly review the basic system using the ECAM electrical pages. Each generator supplies its dedicated AC bus. The two essential buses are normally supplied by AC11. TR1 and TR2 supply DC bus 1 and DC bus 2. The DC BAT bus and two batteries. The APU TR, the DC APU, and the APU battery. For simplification, the component indications had been removed. Let's now present them. As shown, each component can be monitored via its indications. These indications are voltage, current or load for the generators, frequency, and IDG temperature. You can also notice the various connections represented by green lines. Let's now locate the controls available to the pilots and associate them with the components displayed on the ECAM. The electrical panel is located on the overhead panel. For emergency cases, there is an emergency electrical power panel on the left side of the overhead panel. Now let's look at the relationship between the electrical panel and the ECAM electrical pages. The battery voltage can be monitored either on the overhead panel, using the battery voltage selector, or the electrical DC page. Each battery is controlled by a push-button switch. The four main generators and the APU generator are controlled by their associated push-button switches. The external power sources are also controlled by a push-button switch. We will learn how to use them in the normal operation modules. The AC Essential Feed push-button switch enables the pilots to change the supply for the AC Essential bus from AC bus 1.1 to AC bus 2.4. The bus tie push-button switch enables the pilots to isolate one side of the system from the other. You will see and do this in the abnormal operation modules. In case of failure, these push-button switches enable you to disconnect the corresponding IDG from its drive shaft. On the A340-600, a new Electrical Load Management System, ELMS, controls the electrical supply of commercial loads in order to ensure an optimum use of the power sources. Its Electrical Load Management Unit, ELMU, permanently monitors the power consumption, shedding, and reconnecting the loads. The priority between them is defined by pin programming. It is customized according to the airline and depends on the impact on passenger comfort. So, on the A340 600 panel, a new ELMU push button has been added. It enables the pilots to control the ELMS. The emergency generator test switch is used by maintenance only to test the emergency generator. In this module, for presentation purposes, you have seen a ground electrical configuration. We will introduce you to the different possible configurations in the next modules.